Chapter 6.1, we're using the law of sines. We're going to use the law of sines to solve oblique triangles with angle, angle, side, or angle, side, angle, and then use the law of sines to solve oblique triangles, side, side, angle. So just a little bit of an introduction. In Chapter 4, we study techniques for solving right triangles. In this section and the next, we will solve oblique triangles. Oblique triangles are just triangles that have no right angles. And in standard notation, the angles of a triangle are labeled capitals A, B, and C. Then notice that the opposite side are labeled lowercase a for the opposite, B, and C. To solve an oblique triangle, you need to know the measures of at least one side and then any two other measures of the triangle. That could be the other two sides, two angles, or one angle and one other side. Here are the four cases. So two angles in any side, that's angle, angle, side, or angle, side, angle, and two sides in an angle opposite of one of these, so side, side, angle, or we're going to look at three sides, side, 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 and two sides in their included angle, side, angle, side. For the first two cases, that's what we'll be focusing on, is we're using the law of sines. Then the last two cases will require the law of cosines, which is our next section, 6.2. So the law of sines, if ABC is a triangle with sides A, B, and C, then you have A over sine of A equals B over sine of B equals C over sine of C. Or you can do the reciprocal. Sine of A over A equals sine of B over B equals sine of C over C. So let's try the first example. Example 1, given two angles on one side, so angle, angle, side. For the triangle shown, C equals 102 degrees, B equals 29 degrees, and B equals 28. Find the remaining sides and angles. So we need to find A, and we need to find lowercase a, and we need to find lowercase c. Okay, so two sides and the other angle. So in this case, for A, what we're going to do is you take 180, and then minus the other two sides, 180 minus B minus C. So that's going to be 180 degrees minus 102 degrees minus 29 degrees. And therefore, A will equal 49 degrees. Okay, then we're going to use the law of sines. So let's just write it here. Since I need to find the sides, I'm going to use the one where the sides are on top. So A over sine of A equals B over sine of B equals C over sine of C. So the ones that we know are, we're going to use B. So B, we know all of B. So we can plug that in. And then we're solving for, let's start with A. So let me label this as 49 degrees. So we're going to use A over sine of A equals B over sine of B. Now I need to solve for A, so let's just rewrite that. Multiply sine of A to both sides. And then B over sine of, that should be a capital B. So to solve for A, the sine of A is 49 degrees. Times B is 28 over sine of 29 degrees. Okay, then it's a matter of plugging it in your calculator. Make sure you're in degree mode because we do have degrees. So when you plug this in, you will end up getting 43.59 feet. Then the next one, so we need to find C. So I can write this, C equals sine of C times B over sine of B. Okay, so I hope that you can see how I just manipulated it, right? I'm just using B here, and then C here, and then so I just multiplied by sine of C to both sides in order to solve for the side C. Then I plug in what I know. So I know sine of C is 102 degrees times 28 over sine of 29 degrees. Again, using my calculator, that is approximately 56.49 feet. Okay, so 56. And then A is 43.59 feet. So try this example below. So you have A is 30, B is 45, and one side is 32 centimeters. So solve for the remaining angles and sides. If you tried this out, you would have found that the angle C is 105 degrees, side B is 45.25 centimeters, and C is approximately 61.82 centimeters. So let's try this example. A pole, so given two angles on one side, a pole tilts toward the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. We're trying to find how tall is the pole. So we see that is an 8-degree angle from the vertical, so this is 8 degrees. So then we can figure out this entire angle here. So angle B is 90 plus 8, which is 98 degrees. And then from knowing that, we can figure out angle C. So angle C will be 180 degrees minus 98 degrees minus 43 degrees, and so that is 39 degrees. So now we're trying to figure out A. So we're going to use A over sine of A equals, we know, C over sine of C. And then B, we do not know. We don't need that one. We're just trying to solve for A. So to solve for A equals sine of A times C over sine of C. So sine of A is 43 degrees times C, which is 22, over sine of 39 degrees. And then you plug that in your calculator, you will find that is 23.84 feet. So try this example. Find the height of the tree shown in the figure. So we have 23 degrees, 96 degrees. The length is 30 meters here from this spot here. And then we're trying to find the height. So try this out. Okay, so if you tried this out, you figured out that angle B is 61 degrees. I labeled it A, B, and C, and I suppose you could have labeled this H too, however you want to label it. And then I used B over sine of B equals A over sine of A, and then I plugged everything in I knew, and I got 13.40 meters.